What if I told you that in next 30 minutes I will give you the exact roadmap that can take you from a complete Python beginner to mastering it for landing your first data science job in 2025. And the best part that I am going to show you the specific order to learn, including which libraries are absolutely essential and also which one to skip. By the end of this video, you will have a clear step-by-step plan that can use me to break into this field along with where to practice and what to. I am Sumit Kumar Das and welcome to my channel SKT Neuron. Before we deep dive, let me show you the big picture. This roadmap has 6 main phases. First, Python Essential or Python Fundamentals with Intermediates of Python. Phase 2, where we will be covering essential libraries for data science, including data manipulation, data visualization, and data formatting, which also involves fast mathematical operations as well. Then we will see how using Python we can build machine learning models or deep learning models also for computer vision and NLP. Then we will proceed to advanced specializations in Python, including REST APIs, web scraping, database connectivity, UIX dashboards, and rest of the crowd, which will make you apart from the standing out of the crowd. Then we'll see what to practice and how to build the projects. And finally, where to practice. Python platform IDEs also, that also we'll see. So why Python? There are a lot of advantages of Python over other programming languages, but few are the most essential. First, Python has its very simple syntax and very easy to readable. And the most important is its massive ecosystem of libraries. For example, if you see here, reading a CSV file and calculating the average of a columns called salary and print it. It is a problem statement. So this simple problem statement we can do in Python using two to three lines. Where if you are doing this with Java, it will take minimum 50 lines. You can see here. Left hand is Python, right side is of Java. How easy it is using Python to do such problem statements. Next, the most important is its Jupyter and Jupyter notebook support. Notebook support help you just running a single line of code and printing it. You don't need a print statement to print the output of a variable. That's the advantage of notebook. You don't need to run the whole code to print your output of a current logic. You just need to that run that particular logic, it will print it. You can visualize it, what you are trying to build. Just run a code. No need of building a full-fledged application for that, which you used to do in other programming languages. That's the advantages of Python. There are other advantages like it has strong community, it has seamless integration with different APIs and all. It has very good scalability and it is very simple. It is great for production ready platforms. But whatever I mentioned, this is the most important. What makes it apart from other programming languages? Okay, so now first of all we'll see what are the Python IDs, where we can practice Python. We can learn it. There are many sources to learn Python. We can learn it, but where to practice it? So first of all, when you are starting as beginners, especially for beginners, I'm telling, uh, advanced can use any platform. So especially for beginners, when they're starting, it's very good to start with Jupyter Notebook, especially of Anaconda. Anaconda Jupyter Notebook is very good to start with, or even you can install simple Python, ideally, and run there. Or from Anaconda also you have Spider. There also you can use it. It will be using in your beginning phase to practicing your concept. You just read a topic and just write it and run it and get the code, check whether it's working or not, just modify it, run it. So that's how the advantages of Jupyter Notebook is. And next, once you practice your concept, once you go on to building applications or building full-fledged projects, then you can use heavy tools like VS Code, PyCharm, Sublime, or PyDev. These are kind of heavy tools you can use to build full-fledged application or project. Now you say, I am reading for data science. I need to build models. Where I can do that? You have also, you have a GPU based IDs like Colab, Kaggle ID, GitHub Workspace. Those will help you in building machine learning models or very big deep learning neural networks models, because most it use GPUs, or even in Colab you also have option for TPUs as well. But someone will say, I don't have install, I just want to practice. I just want to run without installing anything. That also fine. You have many online editors. I have mentioned few of them here. You can take anything available in the internet, uh, and just practice concept. Again, that is for just practicing concept. You cannot do build application or build models, but you can practice a small concept. You just got an idea about doing something or got click something, you can go and build there. That you can do. Okay, so this is all about where you can practice it. Now we'll go to main topics. So first we have to master the basics of Python. First thing is Python's core syntax. So here you will learn how to declare a variable, how to work with different data types like strings, integer, float, booleans. You have to be comfortable using print statement, adding comments to make your code very good readables, or to add some understanding points, or doing type conversions between different data types, or playing around taking user input and making some interacting program with it. So these are kind of very core syntax of Python. See, so many people make this first critical mistake while doing or practicing Python, is that they try to learn everything about the Python. Okay, you can learn. I'm not denying that, but when you're in beginning phase, don't do this, especially if you want to focus specific to data science. Yes, if you want to become a Python developer, you have to learn everything. Again, they that also have specific steps how to move. But again, for data science, you only need 30 to 40% of whole Python just to build a simple application. You obviously need a lot of things in Python to build a good production ready program. But I'm just telling, to build a basic learn models, just to learn things, you just need to 30 40% of Python to start with at least. Okay. Next, we will dive into control flow. Control flow means like you have if block statements, elif. Also, you have here you will have loops, both for and while loop. In Python, you don't have do while like in other programming language. You have for and while loops here. So practicing, then you have to practice break and continue. How to use break and continue with loops to make your code more controllable, or control the loops behavior. Okay, that you can do here. Okay, then you have to write logic, or write your reusable code using functions. Basically, you have to define functions. It has keyword def. You have to use def to define functions here. You have to understand how to pass arguments and return values from there. Along with that, you have to explore some built-in models like math, random, and date time. Okay, you will use this a lot in data science projects. Believe me, you will use this a lot. Okay. Then the most powerful thing in the Python is data structure. List, tuple, sets, and dictionaries. These are the four most important data structures in Python. You have to understand how to access data, how to update, how to manipulate data using all these four data structures. Just don't go with simple data structures functionalities. Also practice comprehensions like list comprehensions, dictionary comprehensions, along practice of advanced functionality like sorting, filtering. This will make your code very clean and Pythonic. Okay. Before we proceed, if you have missed my previous video on complete roadmap to data science in 2025, where I covered all the points and how to become a data scientist in 2025, then do watch it. Video attached in the description. I will just flash you what is the basic difference between list, tuple, set, and dictionary. I am not going to cover those things here because this is a roadmap video. But just to give a glimpse of that, this is you can like which of the data structure are order, which are not order, which can contain duplicates, which cannot contain duplicates, how to access those data structures. This is just a glimpse of that. You can just take a snap of it and try to grab it. Again, we will deep understand everything in our upcoming videos. So now we will see how to deal with real world data projects, because as you are going to be a data scientist, so you have to work with data. Data means files. There will be different types of file: text file, CSV file, Excel file, JSON file. So you have to first understand how to deal with different types of file, how to read a file, how to write into the file, how to save a file. Okay, with different file modes. Next, as you will be writing code, for sure you cannot write a all perfect code in first instance, or even you cannot say your code will not break in future. So for that, you have to handle those errors. That is called error handling. You have to know how to gracefully manage any unexpected events or errors. For example, division by zero error, file not found error, wrong input error. How to handle them without crashing the program. So here you will use few of the syntax like try block, except block. Along with that, you can have also extra block like final and else block. Those will give some additional features to the error handling. Here you have to learn how to create custom exception classes to handle any specific error, or even raising any custom errors, because all errors are not defined. You may have your own specific errors that you need to define, right? Next we'll explore one of the most important point, that is oops concept. Oops is super useful for organizing large code bases. It is a way to organize code using objects. It helps you writing clean, reusable, and scalable code. Mostly in four oops, you have to learn four core concepts. First is how to create class and objects. As I mentioned, class often called as blueprint for creating objects, and objects are instance of classes. You have to learn here also how to use constructor like an init constructor, and understand concepts like encapsulation, inheritance, polymorphism, abstraction. These are the very core concept in any of the programming language nowadays. So similar same to the Python as well. You have to learn all these things. You may use this while building any machine learning APIs or data pipelines. So it is always good to write a code with hooks concept, with classes and functions, so that it will be always a production ready your code. Then you have to explore Python's functional programming tools like Lambda function. Lambda function basically help you to write quick one-liners, inline anonymous function uh, without defining function using diff keyword. Okay, then you will practice map, filter, and reduce kind of functions, which mostly help you process large data sets very efficiently. Especially these are one line data transformations. For example, use map for squaring each element of a list, or use filter for finding out all users with age greater than 18, or calculate total bill or product rating using reduce functions. So these are some of the simple examples. Again, I just give a glimpse of where you can use all these lambda map filtered, because these are little concept people which try to avoid while using Python, but you have to apply it because these are not mandatory. You can do this using either loop or if else. You can do this, but this will help you in writing code very efficiently and keeping your time complexity very less, because that matters when you are running very large code, you are running your model, and you need to give the output in a fixed duration of time. That time you have to maintain your time complexity. Okay, then we'll be moving out to understand dates and times, because as you are dealing with data, so there will be dates and times. There will be if you consider logs, you have to note down date and times. If you're considering any data in real life, it has to be deal with date and time, so you have to learn how to use date and time module. Here you have to parse, format, and manipulate time based data. For example, doing data arithmetic, or difference between two dates, or getting current date and time. This kind of operations you have to practice here. And of course, you always try to make your code more efficient, more cleaner. So this will there is a very good concept in Python, that is decorators. Okay, so that will help you actually modify any existing function without changing that function. Okay, so you do not need to change the original function to add any functionality to it. That will be helpful in various use cases like logging, authentication. Even you will see while building APIs, you will use those a lot. Then there is a concept called generators, and these are the two most concepts being asked in the interviews. What are decoder generators? Also including lambda and map reduce functions. These are most famous interview questions. Okay, generators help you handle large data sets. This is basically uh, iterating over multiple times and generating one item each time. There will be a keyword called as yield, which will be used to generate each item at one time. Then you have to see how to write code in a clean way, in a modularized way, in a so that you can reuse your each piece of code in multiple places. You don't need to write same logic over multiple places of the your Python code. Your code will get longer, your code will be hard to debug. Now many people say Python programs are very slow. Yes, it is slow, but we have to use Python. We cannot increase the core of the laptop or or our CPUs, right? But we have to fast our programs. How we have to do that? We have further we have to understand multi-threading and multiprocessing. Okay, this is very little tricky concept, and this concept also most people try to avoid because it is little tricky to understand. I'll just give a glimpse what are these things here before we go into next topic. Multi-threading basically means when you are doing any output bound task like downloading files or reading anything from disk or waiting for network responses. So at those places you can do multi-threading. Okay, it use multiple threads within one process, and it shares memory in between them. We'll have one process, one function. It will have multiple threads, and they will divide memory between them. That is multi-threading. While multi-processing is a CPU is good for CPU bound kind of task, like data transformation or model training, where each there will be multiple process. As it is multi-processing, there will be multiple process, and each process will have separate memory space, and we will run each piece of code in each space separately, so that they no one will conflict with others. While in multi-threading, they have one memory. We are dividing memory in between them with multiple threads within one process. Both have different type of use cases, right? That is used for input output kind of task. This is used for CPU kind of task. For example, you are trying to scrap 100 URLs. You will use multi-threading there. But you want to build a or train a deep learning model, or NLP model, we have to use multi-processing there. Okay, now again there is one more concept as concurrency and parallelism. We'll do a little video on this multi-threading and multi-processing, because it's very critical concept, and most avoid concept people do. So we have to deal with concept separately. Okay, there is global interpreter lock. We have to avoid that. You have to schedule your tasks, okay, using like process, pull, and queues. You have to schedule your tasks. You have large CSVs. You have to run large CSV in parallel. That time you have to use pools. You have to build dashboards with real-time updates. There you have to use threads. So these are some of the example where you can use what. Okay. Saying that, we'll go to our next page. That is, what are the essential Python libraries for data science? Okay, so there are many libraries which will be which will be needed while building a data science application, but we'll touch upon what are the bare minimum, or on which you will be working day in and day out, whatever kind of statement you need. You work with machine learning, you work with computer vision, you work with NLP or Gen AI. You have to master these libraries for sure. First is all-time favorite, pandas. This is the library of data science, okay, and you have to master this library, because even this simple library can sometimes, not every time, but sometimes can get your hand. Okay, this help you in doing data wrangling, data analysis kind of concepts. So first we'll see some basics essential of pandas, like how to create data frame, what is data frame, what is series, how to create a data frame and series, how to read different files like CSV, Excel. Again, you can read CSV using normal Python also without using pandas, but that will be very big and it time consuming. In Python, in pandas, you can read that using one line. Okay, then you have to also read the file, and also you have to save the file, right? You have to save those things. Then you have to do little data explorations. All right, you read the file, now you have to understand the data a little bit. So you have to print a few of the rows, few of the columns, because data frames basically means that those are Excel like tables, means you have rows and columns, right? uh, Data frames has rows and it has columns, while series are one column having multiple rows. Okay, so you have to read the data, you have to print first five rows, last five rows. You have to, for that you have to use head and tail. Info or describe will give you some high level information on the data, what are the sum of each column, how many null values are there, kind of things. Okay, then you have to check some missing values are there or not. You have to check data types of any columns. You have to use these kind of functions. Okay, next is some basic operations like indexing. uh, Suppose you want to access fourth row, third column, uh, row after a row having or a row having column of particular values, right? I need a row where a column marks are greater than 100. These are kind of filters you need to put. Okay, so as it is a tabular based data, so you will have some index. So you may sometimes need to change the index. You sometimes need to delete the index. You need sometimes need to add index or sort the index. There will be different kind of operation you can do on that. Then once you read and understand data, you have to do some transformation. Okay, you may need to do some data transformation like sorting, group by, grouping, doing some aggregation like mean, sum, count, kind of thing. Also you can join or concatenate multiple data frames, again at row level, at column level. Okay, keeping access equal to 0 and 1, we can do all those things. Then you can do data pre-processings, because uh, if you have seen, most important concept, or most of the time where data scientists spend time is doing data pre-processings, right? There you have to remove duplicates, rename the columns, then filling missing values, all those things you have to do. Then you have to do, as I said, filling missing values, or converting a normal string, a date time column of string type to date time type. Okay, so there you will again use lambda, map, reduce, kind of things. Okay, so these I have to use. Then you have your next library called as NumPy. NumPy basically is a library which will be helpful in doing mathematical operations while dealing with matrix, while dealing with arrays, because you have list, right? But doing all kind of list operations on very big matrices will be very time consuming. There you need to do very fast operations. Okay, you sometimes need to do element wise operations. You need to add multiply 2 to each element, each row of the matrix, right? uh, or suppose you need to expand your matrix to a particular shape. You have 2 plus 3, you have to make 3 plus 3. You have to aggregate some results. Okay, you need to do some operation either row label or axis label, column label. You have to use axis equal to 0 or 1. Then some of the advanced techniques like putting where conditions, doing generating random numbers, doing some matrix operation like dot product or matrix multiplication or transpose of matrix or flattening the matrix. So these are some of the concept with respect to matrix, because NumPy is all about doing mathematical operations on arrays and matrix, because those will be using while building models, especially in deep learning kind of neural networks kind of models, right? So these are kind of other useful techniques like splitting the arrays, doing some set operations on arrays, tracking arrays, kind of things. Again, if you have a list, why you will use NumPy? Because NumPy is much faster than list, at least 50 times faster, 100 times faster. Okay, that's why instead of using list, we're using NumPy.
Okay, next we'll be seeing some of the visualization we will do in the Python. So there are a lot of libraries in Python which can do visualizations, uh, like there are matplotlib, cbon, plotly. But here in this slide we'll see in detail about matplotlib and cbon. We can see other libraries, but see, if you master these two libraries you can master any other libraries. So those are just advanced plotting, but these are the two most important plotting you must know before going to another plot. Okay, I will recommend first you should understand these two libraries, then you can go to any other visualization libraries. So first of all, if you see matplotlib is a mostly low level custom plots libraries. Again, where here you can plot any kind of basic chart like line chart, bar chart, scatter plot or histogram. But here the benefit is you can add your own legend, you can add your own title, you can add your own label, even you can save your graph. Okay, you can divide your whole screen into multiple subplots. You want 16 plots, 12 plots, 10 plots in the same screen, you can divide into multiple subplots. So those features, low level features, are available in matplotlib. This is one of the example of matplotlib, where it is again example of subplot, where in left hand side I have using line plot and right hand side I have plotted a histogram. It is in a single screen I have plotted. Okay, not two charts I have combined, it's a single screen. This is example of subplot. Okay, so these are some of the basic charting and plotting, but we you have a low level control on it. Cbon, it will be more helpful in doing advanced analysis. For example, you want to build plots on distributions, kd plot or histogram plots, or you want to detect anomalies using box plot, or anomalies means basically outliers, you want to detect outliers, or you want to build a heat map, or you want to build a pair plot for a quick exploration between all the variables. Pair plot basically means it's a relation between each variables with each other. In single plot, all the variables with each other, the relation you can understand. No need of plotting hundreds of plots or in a loop. Single plot is enough. So this will give a advanced level of plotting you can do here. Mostly used for any kind of statistical or analysis, or understand data deeper, you can use this. So these are some of the example. Okay, but this is one of the box plot where you can see how the data are distributed over it and what are the outliers present. And this is one of the heat map. it defining the correlation between the variables. This is the pair plot which I am telling you. Pair plot is a very good plot, which is again it's only telling you directly all the relation between each of the variables. See, there are two more libraries which you will most not be trained about in any other sources, but they are most useful. One is regex, another is JSON. Regex, which is regular expression, which is mostly used to find any kind of pattern in the text or strings, while JSON, which is helpful in doing the data exchange between front and back end, like in APIs, or saving files, saving a complicated file in a good structured way. Okay, now we will move to some of the machine learning libraries. So so basically how you can build any machine learning models using Python. So there are different libraries like scikit-learn, stats model, scipy, xgboost, lightgpm. Most famous are the scikit-learn and stats model. And see, xgboost, lightgpm are algorithm specific libraries. Those are xgboost is specific to xgboost library, but scikit-learn is a very good library which has a all kind of packages starting from building models, doing validation or evaluation of the model, doing hyperparameter tuning, doing feature scaling or data pre-processing, or doing data transformation like PCA or data extractions. All you can do using scikit-learn. Stats model give you to do all kind of statistical test, hypothesis testing, ordinary OLS, finding your p values, all those things. All those things you can do using stats model. SciPy is mostly used to do various statistical functions and test. Okay, but stats model is little bit advanced. Building statistical modeling also it can build sometimes. A simple linear regression you can build using statistical model. But scikit-learn has all kind of models, be it starting from linear regression to logistic regression, or to ensemble like random forest or bagging or boosting, ada boost kind of thing, or decision tree or knn svm kind of models, all, or even clustering models also available in scikit-learn. Okay, it's a very vast library. We will cover scikit-learn especially in some separate video, including pandas and python, also c1 and matplotlib. These are the few of the libraries, 4 5 libraries you should master. Every concept you should know what are those, because you have to use those library day in and day out while building data science applications. Okay, so these are some of the deep learning libraries. Again, keras, TensorFlow. Keras is a high level, TensorFlow is a low level, and that's a good to start with building deep learning neural networks. While PyTorch is more industry famous or industry focused library, mostly used in industries PyTorch, but it's always good to start with TensorFlow and Keras, especially with Keras, to understand while understanding neural networks, how to build simple neural networks. It is very good to build those things using keras, right? So these are the most essential libraries uh, to start when we are going into neural networks or deep learning. Then coming into a specific use case like computer vision, you have some specific library like yellow, simple cb or open cb. Yellow is like building models, simple cb, open cb like doing various operation on images and videos. Okay, then coming to nlp, you have again these things we cannot tell cover in details, because these are a lot of things and you need to understand uh, uh, deep learning and computer vision or nlp before covering these library functionalities. So I'm just mentioning out what are the libraries available you can use for that. But again, we have to cover these libraries in detail in separate video, where we'll cover nlp in detail, or gen AI in detail, for example, or let's example deep learning in detail. So there will cover what these libraries are used for. Okay. um, so like Hugging Face here, NLTK, sparse agency kind of things we are using NLP. If you come to GNI, you have some frameworks like LangChain, LangGraph, Llama Index, Cree. These are some of the frameworks. Like there we have TensorFlow, Keras, or PyTorch. Here we have those some RAG framework, some agentic framework we have. And some are the model where models are available, like Hugging Face has all kind of open source models, where OpenAI or for example Cloud, they have their own closed source models. They will only provide APIs, they will not provide any kind of uh, model to download. Okay. But if you want to do some best uh, uh, text operations, as you see in the previous slide, like analytical, spaCy, urgency kind of, they can do simple text operations, or even they can do very good number of because before to this generative AI we are using those, and we're building very good NLP algo applications using that. Okay. So this is all about specific to NLP or specific to machine learning or deep learning. But now we'll see some advanced concept in Python. Apart from core model building data science, we'll see some good concept which are uh, see, up to this you are able to build a good data science applications. But to be a full stack data scientist where you can build an applications, okay, you can now build a model, do the predictions, uh, train the model, those things you can do. Okay. You can write simple, but how to come build application? For application you need to communicate with the front end. You need to do a continuous communication with front end and back end. You have to take the input from them, you have to give output from them. Sometimes you need get API, sometimes you need post API, sometimes you need to put APIs. Okay, so how to do that? So for that you have some web application framework in Python. One of the example, very simple, or is the Flask. Flask is very lightweight, very flexible and micro framework. Okay. That is very good to start with us as well, because you can in very less number of codes you can build a application. Okay, it is very simple again, it is, you cannot build very heavy application here, but you can build simple web application here very quickly also. Okay. And it is very fast. Okay. So this is one of the example, you can see how quickly you just in these many lines of code you created a application. And see, we are using, as I was saying earlier, right, we're using decorators here. Then we have some more libraries, like we have fast API, which is very fast API. From name itself it is very speed, it has very high speed, and it use asynchronous mechanism to build models. It mostly used in building microservices based applications, which is mostly used in production level, or it basically based upon Swagger and Pydantic kind of uh, toolkit to build this. And as I said, it is very fast, and it is mostly famous for doing what I can say, live streaming data. For streaming data, fast API is more famous, right, for building streaming applications. Okay. Then we have Django. Django is a very heavy application, but it has all the functionalities needed to build any kind of uh, web applications. Okay. How big the application is, how complex the application is, you can build using Django. So it is a full stack Django, but it is very large up. Again, this is time taking to learn Django. So first start with Flask. If you're mastering the Flask, then go with fast API. Then you start building the applications and start building models and building giving some building some projects. But along with that, if you have time, you can learn Django, because Django mostly used by Python developers rather than data scientists. So but it's always good to learn Django. But first try to build projects, and with that, taking some time out, you can learn Django. Okay. These are some of the differences between these three, where you can use what. I just give a glance so that you can get some understanding, uh, why I am telling to learn this and that, and on which order you have to learn. Okay. So now, along with that, you have some additional functionalities you need to do, like you have to connect to database, or you need to do web scraping. So these are few of the libraries available to connect to with different databases like SQL or MongoDB or MySQL. You have to use this library. Again, this is the advantages for everything, even to scrap the web, even to connect database, even to read different kind of files or building models, you have library for everything. So here you have to master the libraries. You don't need to remember everything, but you need to know when to use what and what are the basic functionality available, because you cannot refer always Google or especially ChatGPT to create a data frame, right? That you have to do on your own, but some complex functionalities come because we cannot remember all the functions in suppose example in Python as in pandas or numpy, you have to refer for that. Okay, but now we'll cover the most latest, or you can say interesting part: how to build front end application using Python. Yes, you can build a front end, you can build a dashboard, you can build a UI UX page using Python. There are libraries like Gradio, Streamlit, or Dash. You see, you build a classification model to detect it is a image of cat or not. Okay, using Gradio. You don't need a front end developer right now to build application. You can do on your own. Even though they're not used in production, but still they are very good to practice to do POC level of projects, LMP level projects, or to create projects on your own, even without having, if you learn without having any front end developers, right? And you have Streamlit and Dash board, which will very good building dashboards using Dash and Streamlit. So they are plot Streamlit I think is plotly friendly, where Dash I think is matplotly friendly. Not sure which one is which one, but they are some library friendly. We can use very interactive dashboard. It's not simple dashboard, it has interactive dashboards you can create as well. Okay, so this is a very good application. Okay, so that's wrap up the complete roadmap of Python in data science. How you can use or how you can start with Python, what to cover. I hope this gives a clear direction and confidence to start or level up your journey in this field. But again, this is we're just getting started. It is in the upcoming videos we'll deep dive into each of these topic. For example, each of these libraries, what are the functionalities available in that, or each of the tricky concept like multi-threading or lambda functions or OOP concept, okay, or data structures like list and dictionaries. Those things we'll cover in upcoming videos. We'll deep dive into those, and I will be releasing focused videos every week. And let me know in comments what topics need to be covered in upcoming videos. I will try to make videos on that. And make sure to subscribe to Skid Neuron and hit the bell icon to stay updated. Thanks for watching. I will see you in the next one. Until then, keep coding, keep learning, and keep growing.